Hello and welcome to our channel Data Sciences. Today we are going to solve some 18 power pack problems on estimators. So first of all, what is the standard error of a sample mean? What is the standard error of a sample mean? So you have a sample mean x and bar. What is its standard error? It's calculated by the standard deviation divided by the square root of n. Right? The standard deviation divided by the square root of n. That is the standard error, and the confidence interval is centered around that mean. So you will have confidence interval, mean plus that standard error and mean minus the standard error. So what you need to understand here is that you have normalized the, the standard deviation with dividing by the square root of n. Okay. Now, what is confidence interval? The confidence interval of our confidence, what is confidence level? The confidence level of our confidence interval is whatever we want it to be. It represents our desired degree of freedom. So, 95% confidence interval, which we use most of the times, means that if we compute the interval in 100 samples, then 1 minus alpha percent of the time, that is 95 times, the interval will bracket the true mean, right? Note that the interval is random by nature, but the true mean is fixed. So why limits of confidence interval are random variables? Since sample is random, our interval is obtained by evaluating some function, say mean, at a particular realization. So the upper and lower bounds are necessarily random. So when sample variance follows a chi-square distribution, so this is your sample variance, square of the standard deviation, the sample standard deviation s, which is 1 uh, uh, over n minus 1 sigma xi minus xn bar square, only when the samples are identically independent and identically distributed and are drawn from normal distribution. This we use the sample variance, right, as an estimator. This also means that if the sample is from normal distribution, then it will be a chi-square distribution. What does that mean? N minus 1 upon sigma square multiplied by s square will have a chi-square distribution, and x bar minus mu over sigma square over n will also be normally distributed. Okay, what is this x bar minus mu upon? This is basically z, the normal standard z, right? And what is normal distribution? So normal distribution means x bar minus mu upon square root of sigma square upon n is having a mean of 0 and a variance of 1. And what is then students distribution? So students distribution is nothing but x minus, it should be x bar minus mu upon standard deviation divided by square root of n, which follows a t distribution. The t distribution has n minus 1 degrees of freedom, attributed to Seeley Gossett, who published as student in 1908 this particular theorem. So we draw confidence interval from the t distribution when we don't know the population variance, but we know the sample variance, that is S. So Ci becomes wider and tails become flatter and the critical values moves further away. Fine. And what is the law of large numbers? What is law of large numbers? Law of large number is as n tends to infinite, the sample variance, which is the square of this standard deviation s, converges to the population variance, which is square of the population standard deviation sigma, that is s tends to sigma. Okay, and students uh, distribution, which we calculated here, x bar minus mu upon s divided by square root of n becomes a normal distribution, which is x bar minus mu upon sigma square by n, right? Okay, so this was a law of large numbers. So as sample size goes to infinity, your sample variance becomes a population variance, and the sample distribution converges to the normal. Students distribution converges to the normal distribution. So let there be two samples, x1 and x2, which are drawn from normal distributions. Two normal distributions, one having uh, standard deviation say sigma 1, another having standard deviation sigma 2. So when will their variances, that is s1 square and s2 square ratio, will have uh, f distribution? So only when these two sigmas, the two variances of the sample are same, then it will have an f distribution. The ratio of variances will have f distribution. When do we use chi-square distribution? When we want to make a guess about the population variance. But when we want to make a guess about population mean, we use t distribution. And when we want to just compare the variances of two independent populations, then we use f distribution, right? Okay. What is the confidence interval for mean of 10 and variance of 4? Very simple. So you are given a variance of 4, that means standard deviation is 2. So the confidence interval will be centered around the mean, which is 10 plus minus, say 95% is the confidence interval, so 1.96 into 2. Can you still make a confidence interval if you know the sample samples were drawn from non-normal distribution? Yes, the central limit theorem allows us to use the t distribution. Now, what are 4 rules of hypothesis testing? 4 rules of hypothesis testing, right? They are: number 1, the probability of a type 1 error is equal to the significance level alpha. Right? Alpha is the significance level, it is a type 1 error also. The confidence interval is 1 minus alpha. The probability of type 2 error is beta, the operating characteristic. And 4, the power is equal to 1 minus beta. Let us understand it with this graph. So this is critical value k. So this pink part here is 1 minus beta, the power, and the blue part here is the type 2 error or the operating characteristics. And this shaded part here, black shaded part here, is your half of your significance level. So if you increase your k, your type 1 error reduces. If you increase your critical values, you increase your confidence interval 99% from 95%, 99%. Your type 1 error probability reduces, and but your power goes, but your beta, the type 2 error probability uh, goes up. The blue part goes up, and thus goes up your thus goes down your power, right? So increasing k increases the confidence interval, in reduces the type 1 error but probability, but increases type 2 error probability, increases the beta, and reduces the power 1 minus beta. So this, is there always this trade-off between type 1 and type 2? No. If you increase the sample size n, then both type 1 and type 2 are going to reduce. So you know about alpha, the operating characteristic beta. What are tau, gamma, and sigma? So tau is nothing but a target or the minimum average treatment effect that you are designing your research for. More tau is better, but then it costs, right? Because you have to increase your samples. Sigma is the standard deviation of the outcome. Standard deviation, estimate of the standard deviation of the outcome. So you are estimating that sigma. The sample will have standard deviation s only. Now what is gamma? Gamma is a fraction of sample in the treatment group. So there is a treatment group. So how much you will have a sample. So that will have a control group, that will have a treatment group. So how much of the sample is your treatment group is gamma. Now, how do you determine the power? Uh, you know, how to determine the sample size when you have already decided upon the power of your test. So we use central limit theorem that, and we assume that the difference in treatment and control means is scaled by the standard error is normally distributed. So YT, so mean of the treatment group uh, minus mean of the control group, that is the difference of the treatment and control group, divided by the square of the variances, sum of square of the variances. So sigma square upon nt, normalized variances, plus sigma square upon nc. This will be normally distributed, and this is how we calculate the sample size m, right? So this was about estimators. Keep watching. Thank you.